Welcome everyone. Let's learn how to evaluate the limit of a piecewise function. A piecewise function is given to us and we want to evaluate the limit at some point. We have a strategy for this and strategy is we will check the limit from the left and the right only and only if we are working with the boundary point. In other words, the point where the rule changes. For example, for this piecewise function, the rule changes at the point 2. So therefore, if I want to evaluate limit fx as x approaches to 2, I have to check this limit from left and right to see if those limits are equal. For any other point, for example, limit of fx as x approaches to 4, you can just use the right rule. 4 is greater than 2, 4 minus 2 is 2. You might ask why, because if I approach 4 from the right side or from the left side, I am really close to 4. So no matter what, I will be greater than 2 and I will use this rule anyway. Because it's not a changing point, as you can see, it's not a boundary point. Limit of fx as x approaches to 5 from the left. Left side, right side, x approaches to 5 doesn't matter. At this point, the rule does not change, so we don't care. 5 minus 2, 3. Again, 5 minus 2, 3. Now, limit of fx as x approaches to 2. We have to be careful, because when I check the limit from the right and the left, I use different rules. Limit of fx as x approaches to 2 from the right side. I am greater than 2. 2 minus 2 is 0. Limit of fx as x approaches to 2 from the left side. 2 squared is 4, 4 plus 4 is 8. These limits are not equal. Therefore, we will say this limit does not exist for x approaches to 2. Another piecewise function, limit of fx as x approaches to 3. First of all, we have to question where is 3. 3 is between our second rule, right? So if I approach it from the left and the right, since I will be really close to 3 no matter what, I can just plug in and use the right rule. 4 minus 3 is 1. Limit of fx as x approaches to 2. Now, where's 2? 2 is a point that our rule changes because if I'm lesser than 2, I use another rule. If I'm greater than 2, I use another rule. We have to check the limit from the left and the right side. X approaches to 2 from the right side. I'm greater than 2. 4 minus 2 is equal to 2. Limit of fx as x approaches to 2 from the left side. This time, I'm lesser than 2. X, I just plug in 2. Limits from the left and right are equal. Therefore, we will say limit of fx as x approaches to 2 is equal to 2. Our last and third example, another piecewise function. 0 is where the rule changes. Limit of fx as x approaches to 0. Clearly, we have to check the limit from the right and from the left. Let's check it from the right. I am greater than 0, so I am not equal to 0. I have to use this rule. Limit of absolute value of x over x as x approaches 0 from the right side. Right side of the 0 is greater than 0, therefore it's positive. Absolute value come out as x over x as x approaches 0 from the right. This limit is 1. What about limit of fx as x approaches to 0 from the left side? Limit, again, I'm not equal to 0. I have to use this, f in this rule. Absolute value of x over x as x approaches to 0 from the left side. Left side of 0 is negative. This absolute value comes out as negative x over x as x approaches to 0 from the left. This limit is negative 1. These two limits are not equal. Because of this, we will say limit of fx as x approaches to 0 does not exist.